Welcome to section 3.8 in your AP Calculus class. We're now doing the inverse trig derivative formulas. Here they are, all 6 of them. You must memorize them. No ands, ifs, or buts about it. You must do it. So really there are only 3 formulas to memorize. Sine and cosine are negatives of each other. Tangent and cotangent are negatives of each other. And secant and cosecant are negatives of each other. So if you memorize 3 formulas, you can memorize the other 3. So it's not as bad as it looks. All right, so we're going to do some examples, and we're going to start out with the inverse sine derivative. That's this formula right here. And what you do is you take the angle u, which is a function, you plug it into your derivative formula, and then you take the derivative of that u value and multiply that times it. Typically, we see that the algebra in these problems is a little bit worse than the actual calculus in these problems. So let's go after it. First, let's identify our u value. We're calling this angle u. Our derivative, or as it is in our formula, it's du dx. Du dx is the way you see it in our formula. It's also u prime, same thing. That's equal to 2x. So now we're going to take our little formula and plug it in. 1 over the square root of 1 minus u squared, that's x squared, squared. And then we multiply times the derivative. This is using a chain rule function, the derivative of the inside, which is 2x. So now we're just going to rewrite this. That's a derivative, by the way. We're going to rewrite this and clean it up a little bit. 1 minus x to the 4th. And we'll put our 2x on top. And that is the answer. Next problem is actually from your assignment. We're going to actually do 4 problems from your assignment, which I'm sure you won't complain about. This one is finding the derivative of y with respect to x. So the cosine formula we said is just like the sine formula, only negative. So in this case, our u is 1 over x. To make the derivative a little bit easier, I'm going to rewrite this as x to the negative 1. Therefore, the derivative, or the du dx part, is negative x to the negative 2. All right, make sure you know how to rewrite these functions as either negative exponents or rational exponents, which are fraction exponents. All right, so the derivative of cosine is 1 minus u squared. So that's 1 over x squared times the derivative, which is negative 1 over x squared. I'm going to rewrite that because this is the same as negative 1 over x squared. All right, so we have a negative times a negative. This is all multiplied together. That's a multiplication side. Negative times a negative, that gives us a plus. Let's rewrite this and clean it up, and then we're going to do some fancy stuff. 1 over. All right, so we have the square root of 1 minus 1 over x squared inside the square root sign. We also have an x squared, which I'm going to write in front of this just so that you know it's not under the square root sign. All right, now that's our answer. We're going to do a little bit more to this problem just to make it more interesting and to demonstrate a point. We've just taken the derivative of cosine inverse 1 over x. We are going to do some algebra on this problem to demonstrate something. All right, so algebra on this problem. I'm taking the inside of the square root sign, which is 1 minus x squared. I'm going to rewrite this to be x squared over x squared. That's a 1. I'm getting a common denominator here. All right, so if you have 1 minus x squared, you get a common denominator. This is the same as 1 minus x squared. So then we can rewrite this problem, x squared minus 1 over x squared. And remember that this is underneath the square root sign. So our square root properties tell us we can do x squared minus 1 over the square root of x squared. And we all know that the square root of x squared is equal to x. So x squared minus 1 over x. All right, so let's put that into our original formula. Okay, now this is good enough for an answer, but I'm demonstrating another point. Plus, I'm giving you a little review on algebra, which, believe me, is everyone's nemesis. That's a good word. Nemesis in this section. This should be x squared, and this should be x. All right, so I replaced this square root of 1 minus x squared down here with our little algebra fun that we had. Okay, notice that we can cancel out our x's in the denominator. All right, so now we have 1 over x, square root of x squared minus 1. Now, if I look back at this original formula up here, or the original thing I have circled in red, let's call it, this can never be negative, all right? This answer can never be negative. So to ensure that our simplified form can never be negative, I put an absolute value on the x. Now, this formula should look familiar to you. It is the derivative of inverse secant. And that is really the point we are demonstrating, that the derivative of inverse secant is the same as the derivative of inverse cosine of 1 over x. That was fun, wasn't it? Yes, there is more fun to be had. The next example is also on your homework assignment, and it is page 170, number 10. Okay, so this is an inverse sine function. We want to find the velocity function and then plug in at 4 and for t, and we're done. So we know that u is the angle at inverse sine. So let me rewrite this. U is 1/4 t to the 1/2. And if we take the derivative of that function, we get 1/8 t, we subtract 1, and we get negative 1/2. All right, so that's our u value. I'm sorry, that's our u prime value. Let's move this down here. That's u prime. So the derivative is 1/8 t to the negative 1/2. Multiply by 1/2, subtract 1. Okay, good. Let's use our little formula and start plugging and chugging. We have 1 over the square root of 1 minus 1/4. Actually, I'm going to write this the original way. Square root of t over 4. And then I can square that pretty easily. And times, remember this is the same as 1/8 square root of t. Okay, so 1 over 8 square root of t. All right, so let's just do a little simplification on this problem and see what we might get. 1 minus square root of t squared is just t over 16. And we have times 8 and the square root of t. So so what we really want to do is plug in a 4, right? And figure out the value at 4. So let's do it. Put a 4 here and a 4 here and do all of your fancy calculations. And you should come out with 1 over 8 square root of 3, or if you were really fancy, you might come up with square root of 3 over 24. And those are the numbers you should get when you plug in a 4. Next problem is number 20 on page 170, also in your assignment. So this is just another derivative. We're going to use another formula we haven't used, this inverse secant formula. And we have to take the derivative of square root of s squared minus 1. Remember that this is the same as s squared minus 1 to the 1/2 power. So when we take the derivative, we're going to use the chain rule, 1/2, whatever's inside, to the negative 1/2. And then we have to multiply times the derivative of what's inside, which is a 2s. All right, and then our secant formula is 1 over, and notice our u is equal to s, and our u prime is equal to 1, so that makes it easier, doesn't it? Oh, I like that. So the absolute value of s, square root of s squared minus 1, that's using the formula, times 1. I like that. It makes it easier. All right, simplifying is just some more fun. 1/2 times 2 cancels out. If I rewrite this formula as, or I write s squared minus 1, you actually write this, x squared minus 1, and then we have times an s, correct? S is on top. Okay, that's rewriting the first part, and the second part stays the same because it's pretty simplified. Now we can do one more thing to write these two equations together. We need a common denominator. Not to write the two equations, to write the two terms together. We have a common denominator, absolute value of s, absolute value of s. So if we multiply the first term by absolute value of s over s, that doesn't change its value. It's a legal thing to do. And now we can write this absolute value of s times the square root of s squared minus 1. And this on the top becomes s times absolute value of s minus 1. And that is a really, really, really pretty solution. Lots of algebra. All right, the last problem on our hit parade is page 170, number 24, also in your assignment. So find the equation of the tangent line at the point x equals 2. Tangent, my favorite inverse trig function, because the formula is so easy compared to the others with square roots and blah, blah, blah. It's 1 over 1 plus u squared times du dx. And in this case, our u is x, because it's our angle right here, and u prime is 1. You've got to love this problem. And so we're going to just plug in our u's here in u prime. So 1 over 1 plus x squared times 1. That's our answer for our derivative. We have to plug in x equals 2 and, oh yeah, we have to find a point, right? So then let's plug in a 2, y prime at 2, and this will give us our slope, right? Equals 1 over 1 plus 2 squared, which is 1/5. So our slope is 1/5. Now our point is 2, and we need to take the inverse tangent of 2. Now if you do that in your trusty calculators, make sure it's in radians. In calculus, we actually always use radians. So if you like degrees, you need to convert to radians. And I believe you get a 1.1 if you put this in your trusty calculator. Although you should have 3 decimal points. So actually we want to have 3 decimal points. So I think if you look this up, you get 1.107. And now we just need to write our equation for our tangent line. So that equation is y minus 1.107 equals 1/5 times x minus 2. All right, so remember in calculus and in this class, especially for the AP test, you want your calculator to always be in radians, because some of you might have gotten 63 something something. That's degrees. when you took inverse tangent of 2. Also, you want 3 decimal points. It can be either rounded or it can be truncated. It doesn't matter which one, but just make sure you always put 3 decimal places. All right, we're done with section 3.8.